Alright, pre-EP, here we go. Community ecology. So, we've talked about organismal ecology, one organism, everything about it. Population, a bunch of the same species interacting together. The population can increase or decrease. Well, now we're going to put a bunch of populations, different species together, and we're going to form a community. So make sure that you have your good old highlighter, some writing utensil, and you are ripping raring to go. Let's do this. So, here we go. So, a community. Please highlight that a community is a collection of interacting populations within the same given area. So, you got to be in the same place. This would be like all of the different species interacting in Gunnersville State Park. All the squirrels, the deer, maybe if there's a bear, and they're interacting with all the plant species. So it's a community. If we look at this picture, this is Hawaii. We've seen this. There's all the plant species interacting together. Even though they're all plants, they're different species of plants. And then if you look closely on that rock over there, there is an animal species, a human species, interacting with the plant species. So there are going to be a few things that we look at in communities. One of them is going to be species richness. So, this is the top picture. So I'll put a check mark by it. So this is species richness. This is relative abundance. Well, what does that mean, Miss Vina? Well, let's highlight. Species richness is, please highlight, number of different species within that area. Well, they've labeled them by letters. There's 1, 2, 3, 4. So that's richness. Richness is a number. I have 4 different species here, and it makes up this much percent of the community. So there's 25% of each of them. So it's a number. Species richness, number of different species, number of different plant species. It could be about the number of different animal species. And then relative abundance, please highlight, it's the population size for each species. So, if we look at this picture, we're going to be looking at numbers, but this is how many are in each population. So, if we look at A was up here, so it's all these little fellas. Their abundance, how many of them are there, of that particular species, it takes up about 80% of the community. Well, if we look at species D, if we look up here, it's this little fella. He only makes up, 10%. He's the second largest population in this community. And then B and C, our other 2 plants, they make up 5%. So richness, the number of different species there. Well, there's 4. That's my species richness. There's 4 different types of plants here. My abundance is how many of each of those are there. Meaning what percent of those type A trees are there? Well, 80%. The others are different percentages. So here we're going to look at some interspecific interactions. Now let's make sure, think about the word specific. What does that mean? Does that mean that, we're looking at a certain thing, or are we just looking at the big picture? Specific. You're right, we're looking at a certain thing. And inter means inside. So we're looking at specific things inside a community. Interactions. You interact with people all the time. Maybe it's positive. Maybe it's negative. Maybe it's neutral. So that also applies in animal-plant interactions. So let's highlight this really quick. Interspecific interactions. These are interactions between 2 different species. So if we were to give an example of an interaction, an interspecific interaction between using humans, we could say a human going outside and you're super duper hungry, you're waiting on your mom to pick you up from school, and even the grass on the ground looks good to eat. You are interacting with that grass if you pick it up and you start eating it. Which comes to our first type of, interaction. I'm not encouraging that you go outside if you're so hungry that you eat the growing grass outside, because most likely it will make you sick. Do not think that I'm telling you to go outside and eat the grass outside. That would probably be icky, and I don't want you to be sick. So the first type of interaction we're going to talk about is competition. Now, we at high school, of course, you know, by now, have Aggie games. And that is a competition. So think about it. Think about that word, competition. What do you associate it with? If you play sports, you're competitive. You're in a competition with the other team to win. You want to win the game. Well, if you're an animal, well, you want to win over something. It could be food, could be space, could be a mate. So let's highlight this. Competition is a negative relationship. Why? Because, please highlight, it exists because a resource is in small supply. So resources, give you some examples down here. Again, these are things like food, maybe water, maybe space, and maybe even a mate. So why is it negative? Well, somebody wins, Miss Minor. Why is it negative? Well, in the animal kingdom, this is why. Please highlight. It drains energy away from reproduction. So populations are smaller. If you are a population like this zebra, well, he's kind of getting eaten. Let's leave him alone for right now. Let's talk about these buzzards. Or vultures. Technical name. They are competing for food. They're going to start competing for this poor zebra that is no more. They're also going to compete with this hyena over here. This is like the Lion King in action, guys. They are competing for that food source. Now, if you're competing for a food source, you're trying to live, and you're too worried about getting food. You're not worried about passing your genetics on to the next generation and increasing the population size. That is why it is considered to be negative. Please also highlight, two species cannot occupy the same niche. And I know that you're sitting there thinking, well, Miss Bonner, what does that word niche mean? I don't even know what that means. So, right beside niche, please put yourself a definition. We'll put it in a parenthesis. A niche is kind of like an animal or a plant. It's kind of like their address and their job. So a niche is where they live. They live in a specific place. And then their job. What is their function in the community? Do they, clean up messes like those vultures? Do they, are they a primary food source? Do they put nutrients back into the soil? What's the deal? So niche, their address and their job. And then the other type of interaction that's being displayed on this slide is predation. You've heard of this before, predator-prey. If you were looking at this picture between the zebra and the lion, which one's the predator? That's right. And then the prey, that's right, the zebra. So you've learned about this before. This is a positive-negative interaction. Who gets the positive end of this deal? Is it the lion or the zebra? You're right, it's definitely the lion. And then that poor zebra, he got the negative end of the deal. So please, let's highlight that there's normal predation. This is where a carnivore or an omnivore eats a herbivore. So let's think about that. Carnivore, what do they eat? Do they eat plants or meat? Plants or meat? That's right, they eat meat. So this is a carnivore eating an herbivore. Now what do herbivores eat again? That's right, they eat plants. So herb means plants. So herbivore, that lion ate that zebra. Now another type of predation is herbivory or parasitism. So let's get to that. So herbivory, this is where, please highlight, you're eating plants. Well, why is that? Why does it matter? They're plants, Miss Minor. Well, this is why. Please highlight. They're a different species. Plants are a different species from animals. So whenever an animal, one species, eats a plant, another species, that is considered to be herbivory. And then there's parasitism. If you've ever heard of the creepy word parasite, and you enjoy learning about them, here we go. So parasitism. Please highlight that death does not occur. Everyone thinks that, you got a parasite, you're going to die. Not necessarily. They harm, so harm is done. Please highlight that. To another species. So it's one species hurting another species. And sometimes they say that parasites suck the life out of another species, which is very true. So parasitism, there are two types of parasites. One type is an ectoparasite. Please underline the word ecto and put the word outside. This is a parasite that attacks from the outside. Your example, please highlight, is a mosquito. So mosquitoes love to carry, they're called vectors, fancy science term, for all sorts of diseases. And since they love to carry those diseases, whenever they bite you or another animal, what they like to do is they have these razors on the side of this little mouthpiece that they have. It saws through your flesh, and then it spits this enzyme, remember what enzymes do, into your blood that's almost like a blood thinner. And then it will literally drink your blood, because that's where its nutrients comes from. And it stores it in the stomach, which is right there in that location. So ecto, coming from the outside, attacking. But the opposite of outside is what, ladies and gentlemen? That's right, inside. So that's where endoparasites come from. Endo, please, this is how one of my students taught me to remember this. Endos, it comes from the inside. It attacks from the inside out. These are the ones that are scary. You can hit a mosquito and kill it. But you're an endoparasite, most of the time you have ingested this parasite, and it is living inside of you. And one of the most common ones, please highlight, is a tapeworm. So this is actually the face of a tapeworm. It actually looks, someone said it last year that it looked like a vacuum hose. And what that is that attaches, you eat a tapeworm, usually it's from undercooked meat. And what it does is that tapeworm goes and it lives inside of your stomach and your intestinal tract. And they can grow up to be several feet long. And what they do is they pretty much take your nutrients from the food that you eat to feed itself. And you can easily take medicine that will kill the tapeworm, and you will excrete it out of your body like you would solid waste. But tapeworms, gross. Tapeworms. Alright, I'm going to change the slide. Alright, so here's some adaptations for animals. I like to think about adaptations as, hey, I'm an animal or a plant, and I need to either protect myself from being eaten, or I need to hide myself so that I can find prey easier. It can just come to me instead of me having to go to it. So let's highlight. Adaptations for predators are things like claws, teeth, poisons, maybe they run fast like a cheetah, and muscles. They are all there to help kill their prey and have something to eat. Now, self-defense adaptations, those are for against predators. Those are for the prey. Those are things like long legs. Maybe they, go a little bit faster than their predator. Maybe they can just fly away from him. Maybe they can protect themselves by the big old long horns that they can, use as a defense mechanism to fight off their predator. Maybe it's coloration to help them hide. Or maybe they're like a skunk and they can spray them with a really bad odor that tells them, back off from me, I smell, don't eat me. So let's look at some specific ones. So some specific ones, please highlight cryptic coloration. Please highlight camouflage. That is a fancy word for camouflage. So can you even see this bird? Can you see him? He's a cute little fella. He has camouflaged himself. Think about if you know someone that hunts, they have to blend into their surroundings so that whatever they're hunting doesn't see them. But this little fella, he's hiding from being eaten. Sorry, guys. Sorry, that was my Nana. Anyway, back to ecology. So, again, cryptic coloration, you're hiding from your predator. Well, maybe you have aposematic coloring. Please highlight that these are warning colorations. So if you ever see bright colors like red or this very pretty blue, this is a dart frog from the Amazon rainforest. That color is not for you to go, oh, that's so cute, I want to pet him, he's just so cute looking. That is a warning saying, don't touch me, I'm poisonous. Don't touch me. I got poison all in me. It might leach through my skin and get on you, and then you could, die if you try to eat me, or I'm going to make you really sick. So it's pretty much a, hey, back off type of coloring. But let's say that you don't have warning colors, and you can't really blend in super well. Let's say that you want to just mimic another animal. You want to look like an animal that is dangerous. So mimicry. Think about, I like to call this being a copycat. So if we look at this, there are two types. There is Batesian mimicry, which we'll highlight. Please highlight. It's the harmless look. So it's a harmless animal, like this caterpillar. He wants to look like a harmful organism, like the snake. So you're not harmful, nothing's wrong with you. You're not poisonous or anything, but you want a copycat look like something that is like that snake to tell your predators, back off, I look dangerous, stay away. The second type of mimicry is the Mullerian mimicry. So please highlight that it's something harmful that looks like another harmful. So both of these, this is a yellow jacket and a kookabee. Which one is which? Can you tell? Can you? So this is the bee, and this is the yellow jacket. They're both harmful, so they look like each other. This is a copycat syndrome, but you're also harmful as well. So let's talk about something other than a negative relationship. Maybe you both benefit in this relationship. Maybe you deal with happy feelings. You have a mutual understanding, which brings us to mutualism. Please highlight, this is a positive relationship. Why? Because it promotes coevolution, which means they can change over time together. They help each other, therefore they can both survive. So please highlight that it's positive, just like you learned back in the day. And then commensalism, please highlight that it's a positive neutral relationship. Because there's a positive into the effect, but the other organism is not affected. And an example of that would be, let's put an example before we move on to part 2, would be barnacles plus a whale. Now barnacles are these teeny tiny little bitty aquatic creatures that live in the ocean, and they love to live on the bodies of whales. They get the positive end. Whatever the whale doesn't eat will fall out of its mouth, and the barnacles will kind of reach out and grab it and eat it. But the whale is not affected. The barnacles don't hurt him, but the barnacles don't really help him either. He's just kind of there. So positive, negative. And please highlight, few exist in nature, and it is hard to see them. Why? Because they're so rare. So let's move on to part 2. Part 2 is going to deal with trophic structure. So we want to see how energy flows through different trophic levels. Troph, please highlight, means to feed. So please highlight, trophic structure are feeding relationships. Why? Because troph means to feed. Pretty much we're going to see who eats who in this situation. So please highlight matter cycles. Remember, these are materials that are recycled through the environment, through the law of conservation of matter. which means you've learned this before. Matter is neither created nor destroyed. It's just transferred or transformed, which means whenever something dies, like an animal, it's either going to be put back into the soil for nutrients, or something's going to gobble it up. So energy flow, please highlight that the sun enters the earth, just like in my picture here. It enters the earth and it goes to the primary producers. These are plants. So let's highlight. Sunlight enters the earth, received by plants. And they turn chemical energy, that sunlight, into sugar. Ooh, what's that process called? It's what? Oh, you're right, photosynthesis. So that's how they get their food. Photosynthesis. Well then, please highlight. Eventually, Then the sugars are passed on from organism to the next organism by consuming the previous organism. Whoa, what does that mean? Well, herbivores eat the plants, and then carnivores eat the herbivores. And then, once those carnivores either pass away or something else eats it, these detritus feeders, like fungi, like mushrooms and things like that, they are going to break down that dead carcass. And then other detritus feeders, I like to call them dead stuff feeders, like bacteria, they're going to also break them down. And eventually, through them breaking them down, because that creates a lot of energy, because they got to use it, there's heat left off. Heat escapes into the atmosphere. Now every time, again, think about photosynthesis, one of the products was heat. Every time an animal consumes another organism or a plant, it lets off heat. Why? Because it has to use energy to do that. So it's a constant flow of energy. So please, let's finish highlighting. Eventually all energy becomes heat, which is transferred by metabolism, cellular respiration. So let's go to letter C, food chains. Now you've done food chains before. So food chains, please highlight, they demonstrate an orderly flow of who eats whom. Producers are eaten by consumers, consumers and producers are broken down by decomposers. So, you've done this before. There's this plant, and then this grasshopper eats the plant. Then the mouse eats the grasshopper. Then the snake eats the mouse, or rat. And then the hawk eats the snake. So that's on land. But again, you can have aquatic in the water. Phytoplankton, which are teeny tiny microscopic marine creatures, they're eaten by zooplankton, animal type plankton. Then there's these small fish that eat the zooplankton. Big old fish eats the small fish, and then killer whale eats the big fish. So please also highlight, most chains only have 4 to 5 trophic levels in them, because by the time that they reach the top, like Timon and Pumbaa said, the top of the food chain, there's not a lot of energy left, and this is why. There's something called the 10% rule of energy. And that 10% rule of energy, please highlight that 90% of all the energy is lost through heat by metabolism of that organism. 10% is passed on. So what does that mean? If I am the sunlight, this J stands for joules. Joules is the measurement for heat, which I've written on your paper. So let's say that I start off with 1 million energy units, joules, heat units. By the time that that light hits to Earth and goes to my producer, 90% off goes away as heat. So it's brought down to 10,000. If I have a grasshopper that eats my plant, 90% off of that energy, those joules are given off as heat. Only 10% is given to the grasshopper for energy. it only gets 1,000 joules. And this is going to keep going on. That mouse is going to eat that grasshopper. It's only going to get 10% of 1,000, which is 100. 90% gone is heat. And then whenever that snake eats the mouse, it's only going to gain 10% of the energy from that mouse, which is going to be 10 joules. The rest is going to be given off as heat. Why? Because it takes a lot of energy to break down your food to be able to use it. So this is where I started on your outline. So highlight 10,000 joules of energy is whenever that flower, that grass, goes through photosynthesis. Then the grasshopper eats the plant. 10% of it gets to the grasshopper, 1,000. Whenever that mouse eats the grasshopper, it only gets 10% of the energy that was in the grasshopper, which is 100. And then whenever that snake eats the mouse, it will only get 10% of its energy. And we'll see this with, I got an activity with popcorn we'll do with this. So please highlight each time only 10% of the energy gets passed on to the next higher level in the food chain. 90% is lost on the metabolism of maintaining the life of that organism that's eating. And then a food web, please highlight. It's the model showing all possible feeding relationships. So this is an aquatic food web. So this is a bunch of food chains put together. So these are interacting food chains because not all animals eat just one thing. So also highlight, they could exist within a given area. So please also highlight, essentially, they're interacting food chains. So that's it for part 2. We're almost done with communities. We'll head on to part 3 in just a second. That'll be a separate video. I hope this was helpful, guys.